In this video, I'm going to show you how to make an enemy AI using state trees, an AI controller, and AI perception. We will make an enemy that can follow a set patrol path. They will chase the player upon seeing them. If they hear a sound or get damaged, they will move to the location of sound or damage to investigate. That means check if there's a player. They will start punching the player if they catch you, and if you hide from the enemy, so go somewhere where the enemy can no longer see you, then they will return to their patrol route. I will walk you through each step so you can easily follow along, but if you would like to just access the complete project files, including bonus content and an 800-word document explaining state trees, you can get that on my Patreon. Unlike most following tutorials out there, I will take regular short pauses to explain key concepts, so without further ado, let's get started. We're going to make a new project in the third-person template. Just call it something like state tree project, or whatever you want to call it, but it's very important, do it in the third-person template so you can properly follow along. Once we've opened the project, we're going to go to plugins and we're going to search for state tree. The normal state tree plugin is enabled by default, but we need to add the gameplay state tree plugin. So add that, then restart your computer. The next setup thing to add is the nav mesh bounds volume. We're going to add this to the world and we're going to expand it so it covers the entire map or the entire area that we're going to use. And what a nav mesh bounds volume does is it defines the area in which the enemy AI can perform calculations. If you want the enemy to move to a location, it has to be within this nav mesh bounds volume, because otherwise the computer can't do calculations to find out how to get there. If you press P on your computer, you can see all the debug areas where the enemy can move. Obviously if it's green, it means it's good and the enemy can do calculations there. Now we're going to create the enemy, so go ahead, search for a character, just a normal character class, call it BP_enemy. Then we're going to make an AI controller, so if you go to your content browser, go to blueprint classes and search for an AI controller. Just use the normal one, we don't need any others, the default AI controller, call it AIC_enemy. The AI controller is the brain that controls the AI character, the body. The character handles the movement, animations, and physical presence, whereas the AI controller handles decisions like choosing where to move or when to attack. This separation makes it easier to manage and reuse AI logic across multiple characters. Next, we're going to make a state tree. We're going to go to artificial intelligence, then just click on state tree. Make sure it's the state tree AI component. We want that one, not the normal one, because it has some extra features. Then we're going to open up the enemy, and we're going to add some of the default features we need. So go to the skeletal mesh and give it the Mani mesh. Then we're going to give it the ABP_Mani for the animation class, so it has a little bit of movement. Then on the location, give it -89, and on the rotation, give it -90. This puts it into the proper location in the capsule. Then search AI in the defaults panel. Make sure you click on class defaults so everything pops up. Then scroll down to where it says pawn. Then change from auto possess AI to place in world or spawned, and change the AI controller class to the one we just made, AIC_enemy. Now go to the AIC_enemy, our AI controller, and add a state tree AI to the components class. Change this to ST_enemy, the state tree we just made. This will run the actual state tree for us. Now we go to our enemy class, we just spawn it into the world. Nice and easy, we just place it. We're going to add an actor, we're going to call it BP_patrol path. This is going to be how we're going to define where the enemy goes on his patrol route. So open that up and add a spline component. This is like a line that you can drag along the ground, which is basically a line that the enemy can follow for his patrol. Add a variable to the BP_enemy, call it patrol path, and make it of type BP patrol path. This is how we're going to set it so the enemy knows which patrol path to use. Place the patrol path into the world and you're just going to drag the points at the end. Just click on it and drag, and then you can see how the spline moves. If you hold Alt and left click, it duplicates the point and drags it even further across the floor. Make sure to press Alt and left click, because if you don't, it will just drag the same point, and we want to duplicate and make a new point. It has to go in a loop. It doesn't need to exactly touch, but it's ideal that it goes in a loop because, you want your enemy to go in a loop around his patrol path. Interfaces in Unreal blueprints let different blueprints communicate without knowing what the other blueprint is. This is extremely useful in modular systems like AI or state trees. Let's say you have a state tree task that needs to make the player take damage, but the state tree doesn't know what kind of actor the target is. It could be a player, enemy, or dummy. By using an interface, for example take damage interface with a function called apply damage, you can call apply damage on any actor that implements the interface and avoid casting to specific classes like BP player, which keeps your system flexible and reusable. Now we're going to add a new interface, so search for interface, call it int_enemy, int for interface, then go into the functions and change the function to called getPatrolPath. With an output of the patrol path, so call the output patrol path, give it a variable type of BP_patrol path. This is how we're going to pass the information of what patrol path to use from the enemy to the AI controller, so the AI controller can make the enemy move along the patrol path. Go to the enemy, go to class settings, go to implemented interfaces and add the new interface we just created. You'll see a grayed out function pop up, just double click on that and input the patrol path to the output. Now go into the level, go to your enemy. First you'll actually have to make sure the variable is instance editable and expose on spawn, which I didn't do, but now if you go to the enemy, you'll see in his default classes a patrol path variable which you can set to the patrol path in the world. Instance editable means that you can change the variable's value in the details panel of the placed blueprint. Expose on spawn means that you can set the variable's value when the object is created using spawn actor. This gives you control over blueprint settings when creating or editing instances. So now our enemy knows what patrol path to use. So if we go to AIC_enemy, we can search for event possess, promote the possess pawn to a variable. Now as soon as we possess that enemy, we can say get patrol path. Because we just gave the enemy what patrol path it is, now the AI controller knows what patrol path to use, so we can do some variables on it. So promote that to a variable. Search for get spline, because the variable in itself isn't a spline, it's an actor, and we added a spline to the actor, so you'll have to get the spline from it. Search for get number of spline points. Then promote this to a variable, call it something like total patrol points. Duplicate that to create a new variable called current patrol points and just set that to 0. This is how we're going to find all of the patrol paths we have, and we're going to move from one to the other. Go to the content browser, search for interface. We're going to make another one for the enemy controller, call it int_AIC, IC for controller, and just call it patrol. Make that function patrol, no inputs, no outputs, we just need the function call. We need to add the interface, go to implement interfaces, add it. Now you'll see the key on the side called patrol, double click on that to get the event. We're just going to print a string to say patrol, just for testing so we can see that it's actually working. Go to the state tree, make a new state called patrol. Now we need to make a new task, so the task that will run when we hit this state, so click on new task, put it wherever you want, call it stt_patrol. Now in this we need two things every single time. We need event state and we need a finish execute. On event execute, this is what runs when the task starts. It's where you put the AI's action, for example move to a location. Finish execute is where the task ends. You tell the system whether it succeeded or failed. That are used to structure the logic in a behavior tree task node. A very important distinction though is that finish task doesn't just finish the task, but it finishes the entire state. Now we just going to have the event state and then make a variable called AIC and then put it of type AI controller, drag that into the world and just fire that patrol event we just created on that interface. Now we're going to say finish task, which finishes not just the task, but actually the entire state. So that's going to say we get to the patrol, we fire patrol, then we end the state. But now we need to call the task from this state, so just click on that plus button next to task, search for that task we just made, stt patrol, give the context of AI controller. In state trees, a context is a reference to an external object or system that the state tree can use during execution, specifically the AI controller context. When setting up a state tree for AI, Unreal will pass in the AI controller as the context. This allows the state tree to access the pawn, blackboard, or world via the controller. This matters because many tasks or conditions need to know what AI is running the state tree, where the controlled pawn is, or what perception or data is available. Instead of getting these manually in every task, Unreal injects the AI controller as a default context so all state tree tasks can access it. In short, a context is a way for tasks to access external information or systems safely and consistently. And on the state transition, just say as soon as it finishes, uncompleted, go back to patrol. Now when you run it, you can see he keeps saying patrol over and over again. This is because we're hitting the patrol task. We do it, we fire this event, then we finish the task and it keeps repeating. Now we're going to make another custom event called increase patrol point. This is what we're going to run after we've done our patrol to know to move to the next patrol point. Search for AI move to off of the event patrol and implement the enemy that we made as a variable from earlier on event possess. Now we get the patrol path, we search for get spline because it's not a spline in itself, remember it's just an actor. So we get the spline, then we want to get location at point or get location at spline point. Change the coordinate space to local and plug it into the destination. Sorry, to world and plug it into the destination. Implement the current index. Then on success, we're going to trigger the increase patrol point. Now when an increase patrol point fires, we want to increment the current patrol point and we're going to check is it greater than the total patrol points. If it is, then we're going to set current patrol point back to 0, then we're going to trigger patrol again. What this does is it makes sure that every time we move to a patrol point, we're going to move to the next one, but if we're at the last patrol point of the entire path, we're going to go back to 0, which is the start, and that's why it's important. It's a loop because it just means we go from the end of the loop to the start of the loop. He's not actually moving there, which means I made a little bit of an oopsie, so let's see what I did. Or didn't do, rather. I didn't check the patrol points. I had greater than 0, so go back, just make sure you're saying greater than 0. Now he will move around the patrol path. Now we're going to open ABP_Manny, the default animation blueprint, because there's a little problem. We're going to go to locomotion and we're just going to remove the idle state, because as you could see, he's just gliding around the patrol path. We don't want that. I want him to actually look like he's walking. There's a little bit of problem with the default one, so if we just remove the idle state, now he'll actually be running. Great. An enumeration is a list of named values you can use to make your code easier to read and manage. For example, you could have an enumeration for movement activities, such as idle, walking, or attacking. You can use it to switch AI states, select behaviors, or organize game logic clearly. We're going to create an enumeration. We're going to call it E_enemy senses. This is how we're going to start making the enemy actually interact with the player. Notice the player, so go into this enumeration, add 3 and call them sight, hearing and damage. These are the 3 senses we're going to test for when we add AI perception. Right here we add AI perception under components on the AI controller. AI perception is a system that lets AI characters sense things, like seeing a player, hearing a sound, or feeling damage. It gives the AI the ability to react based on what's happening around them. Go to sense config, add 3 senses, add AI sight config, AI damage sense config, and AI hearing config, and set the dominant sight to AI sight. The dominant sense to AI sight. We're going to give the sight a sight radius of 750 and a loose sight radius of 1250. We're going to put detect to all 3 of the boxes. The age doesn't matter in this situation. The other 2 are fine. The other 2 are fine as the default settings. So we're going to click on perception updated and we're going to get returned a list of updated actors. we're going to say for each loop. And this means that every single one of the actors that we've just changed something we know about, we're going to check over it. Now, because we're checking 3 senses, we're going to make a function so we can reuse it, make that function, call it canSenseActor. Add 2 inputs, one of them is going to be the actor of type actor, and the other one's going to be the sense of type E_enemy senses, or whatever you called your enumeration. Drag in the AI perception and search for get actor's perception. This gives us all the returned information that we know about the actor that we input. Break off the info value and do a for each loop on the last sensed stimulus. We're going to get class sense for stimulus, and we're going to say equals to check if it's the same as the sense that we input. So we do a branch afterwards and then a return, but now we're going to come back and we're going to get the sense we input. We're going to do a select, we're going to plug it into the equals, and we're going to choose the class. Here I'm doing it slightly wrong. I'll come back and correct it in a sec. I'm going to play. There's going to be a little error. I'll come back and then I'll correct it. So for now, just leave those empty. We'll come back and sort them properly, but you do need to do this next part. You need to return that array element as an output of the function, break off it, and then we're also going to return successfully sensed. So now we know, have we successfully sensed the enemy or not? This basically means, have we seen them for the first time, or have we lost sight of them? Have we heard them for the first time, or have we stopped hearing them, etc. We're also going to output the actor. Now off the sequence, we're going to do 3 times, we're going to do 3 canSenseActors, and we're going to change the first one to sight on the enumeration input, the second one to hearing, and the third one to damage. We're going to input the actor, just have a little branch to check off the end. Can we see the player? Can we not see the player? This is where we're going to change it. Change those selected senses to AI sense sight, AI sense hearing, and AI sense damage. Make sure you input the actor for all 3 of those functions. Now if we play, you can see every time we go into the enemy's vision, he will say can see player. Every time we leave the vision, he'll say can't see player. This is the difference between the true and the false. If we return true for successfully sensed, it means we've entered his vision. If this is false, it means we've left his vision. It's the same for hearing and damage. We're just going to close some of those tabs to make it a little bit cleaner. Then we're going to, if you press Control P, it will give you a way to search for any of the items. You could search for it manually in the content browser, but this is a little bit quicker. So search Control P, open your third person character, then get the keyboard event for N and get the keyboard event for M. We're going to set up some default practice demos for how we can send damage and send noise. So search for report damage event, give the instigator as self, and we're just going to say get actor location and put that in. That's where we're damaging from. We need to put in a damage amount, put it to 100. And for the damaged actor, we're just going to say get actor of class and then search for BP_enemy. This is not the best way to do it, and in a game you wouldn't do it like this, but this is just for testing because we're not caring about how we're doing the damage. We just want the enemy to detect the damage. If you get my Patreon version of this, I implemented a feature where you can drop a bomb which will explode and it will have a hearing radius around it so the enemy will hear the bomb going off. And if you also get that, you will see that the player can punch the enemy, which will then trigger the damage. So instead of these default events, you get a little bit extra. Off M, we're going to say report noise event, get actor location, put in self, make sure there's a loudness, and make sure there's a range. We're going to print just to make sure it's firing. And by the way, report noise event and report damage are not the same as play sound and apply damage. If you try and use apply damage and play sound, the enemy will not detect them. It's not the same thing. Report damage doesn't actually do damage, it just tells the enemy to react as if there's been damage. It's the same for hearing, so if you want to actually apply damage, you need to still call the apply damage event because they're not the same and they serve different purposes. One is just to say, hey, you've heard something, or hey, you know, react to this damage, and the other one say you've actually been damaged, reduce your health. We're going to fire 2 branches off both ends of these canSenseActors, and we're going to add print strings just to debug and make sure they're actually firing. Compile, save, play the editor. Now you can see if we press N, he's going to say damage received. If we play M, we're making a noise. Now damage is working right now. Every time we press N, he can hear the damage. He's not detecting our noise, and I'm going to fix that in just a moment. But if you look, every time it says damage received, that's because I've pressed N, we've applied some damage, and he's detected the damage. To fix the hearing, go to the AI perception, go to the hearing config, and make sure you check all three of those boxes. Make sure you're testing for enemies, neutral, and friendlies. Now, when we press M, we're playing a noise and it was heard. As you can see in the top right corner, every time we press M, we see printed noise was heard. That means the enemy has detected some of that noise. So again, to fix that little issue, just make sure you go to AI senses, go under your hearing config, go to the detection, and check all three boxes for detect player, detect enemy, detect friendly. If you can't see it, just go under and scroll down the list and just go through each of the categories. It's there, it's quite obvious. Here I'm just tuning down the max range because 500 was a little bit too loud and he could hear us from the entire map, so we'll just make it if we're a bit closer. Now he can't hear us, but that's just because we're not in range. If he comes back round and we play another noise, now he can hear us. We're going to go to our AI controller interface, add a new function called chase player. Again, we just need the function, we don't need inputs or outputs. Then we're going to make a new variable called attack target and change it to type of actor. Every time we successfully see the enemy, we're going to set the attack target, and every time we don't see him, we're going to set the attack target to nothing. So set the attack target to the outputted pin. For successful, and for false, just leave it blank. This means every time we see the player, we are creating a variable which holds the reference to the player, and if we lose sight of the player, we are clearing that reference so we no longer have reference to it. Here I'm just organizing a little bit more, adding some comments. You don't have to do this, but it makes it look a bit neater and you can better understand the code. So just drag over all, just do a box drag, press C, and it will come up with the comment. Make sure you double click on the chase function on the side under interfaces to make this function pop up. Now we're going to search for AI move to. We're going to put in the attack target, convert it to a validated get. Validated get checks if a variable, like a reference to an actor, is valid before using it. It helps prevent errors or crashes if something isn't set or has been destroyed. If valid, it runs the logic. If not valid, you can handle the error safely. Then we make a new state in our st_enemy, call it chase. We're also going to make a new task to go along with this, so search for a new task, stt_chase. Make sure you trigger the event enter state, then add a variable called AIC of type AI controller. In state tree AI, the concept of a task and a transition is a bit different than in an animation blueprint. A task is a piece of logic or behaviour that runs when a state is active. For example, move to player, play attack animation, or wait for X amount of seconds. A task defines what the AI should do in that state. You can create custom tasks or use built-in ones like move to, wait, send signal, or blueprint task, where you add custom logic. A transition is the rule or condition that moves the AI from one state to another. This could be a condition becoming true, for example play a scene, a signal being sent, or a task finishing successfully. You can define transitions in the state tree by selecting a state, adding a transition condition, then choosing where the state next goes. Drag that into the event graph, then search off that chase player. This will call a reference to the interface we just implemented to fire the event. Then just search for finish task. If we don't do this, we never finish the state and we'll never move on. Now we need to actually add this task, so next to task, click on the plus button. It will give you that input value that you need, so just go on the side and make sure it's linked to the context. Then on transitions, add a transition on event, then change the priority to high, make sure it transitions to chase, and on the required event, create a new tag, call it chase, and make sure the source is on that first one that pops up, because otherwise it will work. And what this does is every time we call to that tag, we can call to it from anywhere, it will now reference that event and trigger the state change. We're going to make another tag, just call it patrol. And then we're going to have another on event transition change, which goes to patrol. On our AI perception for site, we're going to drag in the state tree and we're going to say send event, or rather send state tree event. On the event, we're going to make it, drag off and search make, and this will take 3 inputs. It'll take the tag, the payload, and the origin. The payload and the origin we don't need, but on the tag, just search for chase, because now this means that every time this event triggers, we trigger the change of state from patrol to chase, or from whatever to chase, and the same for if we lose sight of the enemy, but this time we're going to send the state back to patrol. I'm just changing the location of the enemy because where he is now, as soon as we press start, he's going to see the player and he's going to run to the play. He's not actually going to run his patrol, so we're just making he starts his patrol first. I'm just changing the max walk speed of the enemy. You don't have to do this, this doesn't really change much, it's just to make it easier to run away from the enemy for testing. I also got rid of the finish task on the STT_chase. Now, as you can see, every time we go in the view path of the enemy, he's going to start chasing us. And if we leave his view, I just did it then when I ran behind him, he's going to return back to patrol. So if he sees us, he'll chase us. If he can't see us anymore, he's going to return back to his patrol. We're going to add a new state, call it investigate. Then we're going to add a new task, call it STT_investigate. Off the function, just search for event enter state. This is the default one we almost always need. There are some others, but this is the one we almost always use. Again, just add another variable, AIC of type AI controller, so we can reference the controller from the context in the state tree. Add the task and give the context for the task so it runs. Drag in the AIC, search off it and search for cast to AIC_enemy and cast to AIC_enemy. We're going to go back to our AIC_enemy and create an event dispatcher on investigate finished. We're going to drag off the AIC enemy in our task STT_investigate. We're going to say assign on investigate finished. This creates a bind event and an on investigate finished. Off that investigate finished, we're just going to say finish task. Off our hearing sense, we're going to break this output stimulus. We're going to say AI move to. We're going to input the enemy. And we're going to input the stimulus location. So this way it's going to move to wherever it heard something. On success, we're going to call investigate finish. We're going to call that event dispatcher we just made. On patrol, we're going to add another transition. We're going to say trigger on event, and it's going to go to investigate. It's going to be of high priority, and the tag, we're going to make a new tag, call it investigate. Make sure the source is selected. That's why I get an error there because I didn't select the source. Now we just click on the investigate tag, and every time we reference this tag, we're going to move from patrol to investigate. On investigate, we're also going to create a transition on state completed. We're going to go on state succeeded, sorry, we're going to go to patrol. On state succeeded, we're going to go to patrol. In our AIC underscore enemy, we're going to copy and paste that little couplet of 3 nodes to send the event. You could do this again, it's state tree AI, search for send event, send state tree event. Make sure that the tag is set to patrol this time. Ignore the tag that I just left in there. Right now it says patrol. Later we're going to come back and change that to investigate. But for now I didn't realise, I'll notice in a minute. But in that tag section, like I said, you don't want patrol, you want to have investigate for both of them, because this way we're triggering investigate. When we played a sound, he turned to start facing the sound, then he saw the player, so he started chasing the player. So here, if you press N to trigger damage, you'll see he starts moving to us. Make sure the tags are both set to investigate, not patrol. On investigate, add the transition on event chase. Now if we trigger damage for the enemy, he starts moving towards. And then he saw the player, so he started moving towards the player, but then we moved behind the wall, so he returned to his patrol. We're going to add a new folder, call it anims. I'm going to import an animation I have. You can find this if you get the project files on my Patreon, but it's just a simple anim, it's a simple punch anim I retargeted from Mixamo. We're going to create an anim montage, call it an_punch. We're going to go to our enemy, not enemy controller, our actual enemy blueprint. We're going to create a custom event, call it attack. We're going to search for play montage, just the play montage, not play anim montage. In skeletal mesh component, just drag in the mesh. And on montage to play, we're going to search for an_punch. We're going to create an event dispatcher called attack finished. We're going to drag it, we're going to call it uncompleted. An event dispatcher is a way to broadcast a custom event from one blueprint to others. For example, when a boss dies, you can broadcast on boss death, and all listening blueprints, for example UI, doors, etc., react. It's like shouting, "Hey, something happened," and other listening actors can choose what to do. In our AIC underscore enemy now, we're going to make another custom event, we're going to call it attack as well. We're going to get our enemy, we're going to cast it to BP underscore enemy. Then we're going to drag off and we're going to search for attack. We're going to say assign on attack finished. Then on attack finished, we're going to create another event dispatcher called on attack finished again, and we're going to call this event dispatcher after this event. Compile and save. Go back to our state tree, make another state, call it attack. Make another task, call it STT_attack. Search for enter state. We're going to make a variable, call it AIC of actor. We're going to make a variable called actor of type actor. Make it instance editable. Then go to tasks, for our attack state, add that attack. We didn't compile before, so we won't see it pop up. But here we search for get AI controller, cast to AIC underscore enemy. Drag off that and search for attack. Search for assign on attack finished. Then on attack finished, search for finish task. Create a new event dispatcher in our AIC enemy, call it on chase completed, and another one called on chase failed. We're going to make a little update to how our chase works. Go to our chase event. I'm just going to add a little comment so it's more readable. On success, we're going to call on chase completed. We're going to get our state tree AI. We're going to search send state tree event. So on the failed pin, we're going to search for this. We're going to make sure we're sending this event, make the event, and give it the tag of patrol. The payload and origin are, as usual, not important. Call on chase failed after we lose sight of the enemy. Go to our state tree, go to our state. This time we're going to cast to our AIC underscore enemy. We're going to drag off the enemy. We're going to say assign on chase completed. We're going to say finish task. This time we're going to say on assign on chase failed. And we're going to say finish task, but this time succeeded will be false. We're going to go to chase, we're going to add transitions. We're going to say on state succeeded, go to attack. Then another one, on state failed. We're going to go to patrol. We're going to change the position of the attack state, going to move it above investigate, under chase. We're going to change the transition to on state succeeded, go to chase. Go to the state tree, go to our attack function. We're going to change how we get the controller. We're going to make a variable, call it AIC, give it of type AI controller. We're going to input it to that cast instead of getting the actor. Now when we start, if the enemy sees us, we play the sound, he moves to the sound, he checks it out, there's nothing there, so he walks back to his patrol. We damaged him, he turns around, this time he sees us, so he chases us, he gets to us, he starts punching us. Here you'll see a little bit of capsule clipping, it's the weird camera movement. Go to your player, BP underscore third person character, again control P to open this asset, to open the asset selector. Then go to the third person character, go to the camera boom, scroll down, find do collision test and disable that. So now if he punches us, you'll see that there's not the weird clipping. And now we're done. So the final behavior, if we apply some damage, he'll move to the location where he sensed the damage. And if we play a noise and he's in range, he will turn around to start moving towards that sound. If he sees the player whilst he's moving, he'll start chasing them, and if he reaches them, he'll start throwing punches. But then, if he loses sight of the player, he will go back to his normal patrol. For example here, he can no longer see the player, so he's patrolling. Thank you for watching to the end. I hope you managed to get the system working, and if for some reason you're having troubles with it, you can get the working project files from my Patreon. And if you're an avid UE5 learner and want to become a part of a rapidly growing development community, then come and join my Discord. We're nearly at 200 members.